Welcome to my latest module overview video. I'm going to look at the Mutable Instruments branches module, which is a dual Bernoulli gate, which is like a virtual coin toss based logic. It's got two channels and each of them can route a single trigger or gate at its input to two different outputs. The output is random. Again, this can be thought of as a coin toss process, and you can control the randomness with the probability knob and also the probability CV input. I'll go through the features and patch examples, and as always, feel free to ask any questions as you're watching the video and leave a comment below. So let's get stuck in. So I'll start with a simple patch here. I've got a saw wave and a pulse wave being mixed into a filter. I've got my clock going into the branches input on the top channel, with the A output triggering an envelope which is moving the filter, which you can hear. The B output is triggering a different envelope so we can get some variation based on this coin toss probability based logic on the module. I've got my clock running into the top channel on branches. The A output is triggering an envelope which is opening a VCA with a single waveform in it. Output B is triggering another envelope which opens up another VCA channel with a different waveform from the same oscillator. The input to the first VCA is a triangle wave, and then the input to the second channel on the VCA is a square wave. As the clock goes in, branches create variation of which envelope is triggered and therefore which VCA is opened, so it's choosing which waveform passes. As the input to channel 1 on branches is normal to the second channel, I've got another two envelopes and another two VCA channels that are being mixed so we can get different waveforms overlapping, and branches decides on each step which one is triggered. So I'll speed up the clock going into branches now and add a pitch sequence to the oscillator providing all these waves, and just play around and start to set things in motion. So with a single oscillator, branches, a quad envelope and a quad VCA get quite a bit of variation just within one sequence. Here I'm going to create two overlapping melody sequences. I have two triangle waves going into a mixer, and the clock that's going to my sequencers is going into branches. Plugging in the A output of branches, this is sending the clock to one sequencer, so it moves one sequence and one melody. Adjusting the probability, we can affect how many of those clocks go out of output A. And then plugging in the B output, this is passing clock to the second sequencer and second oscillator providing the triangle wave. This creates overlap as one sequence holds and the other moves, creating these overlapping melodies and harmonies between the two lines. Here I'll use branches to move two filters and create some stereo filtering with one filter panned left and the second panned right. Both filters have the same input, and my clock is going into branches with the A output going to one filter being triggered by an envelope and the B output triggering another envelope to open the second filter. So if you make sure you're listening on high quality on YouTube to make sure you get the stereo audio. Branches also has a feature where if we hold down the button on each channel, it will hold the output high until it changes. So rather than the clock being sent in and getting an output that would go A, B, B, A, B, for example, it would hold A until B changes and then hold B until it changes back to A, giving us some different rhythm sequencing. And as before, with the knob we can adjust this probability. We can also adjust probability with the CV input, so I'm using a DivKid LFO, and we can influence the outputs. look at audio rate on branches now, and I've got a square wave from a Dixie oscillator at the input. As we pitch that up and down, we're getting a very digital sort of sample rate style reduction sound. As we move the probability knob round to lean towards the B output, which isn't connected, the A output gives us a crushed digital style clock noise. Taking the B output and then panning the A output left and the B output right, we can get some stereo crossover with the square waves and the noise mixing in left and right. I'll add in some probability CV now, which is going to come from a ramp wave LFO, and you can hear this pan the probability knob around. Triangle wave at the probability will pan the knob back and forth in pendulum style. Sticking with audio rate clocking, here's a square wave again, but this time I'm going to mix it into a bass line. I've got a higher patched harmony on the Dixie oscillator, which is a square wave going into branches. I'm going to mix this against Livewire AFG's waveforms providing the bass. These are all mixed on the Manhattan analog filter. So we can start to adjust the branches output and change that square wave into the clock noise and that sort of crunchy digital sound that we were getting from the previous patch. Here I'm going to use branches as a modulator to colour noise. I've got the noise output from an Erica Polyvox modulator at the input, and as we bring the probability round to the output that we're using, we get all sorts of crackles and pops all the way around to the normal noise when it's all coming out of the same output. Taking both outputs, we can get some stereo movement by panning them left and right, and one side will be richer and fuller with the noise and the other more crackly as we pan between the two. Again, listening in headphones and high quality on YouTube is recommended to check out that stereo panning. In this final patch, I'm going to look at branches for drum triggering. I've just got a clock input into the branches, and the A output is triggering a closed hi-hat on the mutant hi-hats module, and the B output is triggering the open hi-hat. Here's a mutant hi-hat so you can see that unit and see it triggering both sides. So you can see the two sides, both closed and open, are being triggered separately. As the input to channel 1 on branches is normal to channel 2, I'm going to use output A on channel 2 at the bottom and then add this into the accent input on the mutant hats. So the probability on channel 2 knob now sets the amount of accents coming through to accent both the closed and the open hi-hat. So just with a single steady clock source, it's really good for just splitting the sounds out, triggering two different drum sounds and creating accent patterns as well. So I've kept all the patches fairly simple here as sort of starter patches that you could expand and then build up voices or other sounds and rhythms around. It's a really great unit that can turn a single clock toss into lots of variation. As always, I hope you've liked the video, hit like and subscribe below, and feel free to ask any questions in the comments.